we are going to continue our factoring review. So last time we looked at the general steps that you would take in factoring and different methods. For example, always checking to see if you could factor out a greatest common factor first. We talked about if you have a binomial, check if it's a difference of squares. If you have a trinomial, check if it's a perfect square. If you have a trinomial of the form x squared plus bx plus c, so a is equal to 1, use a sum and product method using the x. And if it's a trinomial of the form ax squared plus bx plus c, where a does not equal 1, then use factoring by grouping or the xbox method. But this week we will look at more closely at factoring binomials to see if, like using the difference of squares formula, looking to see if things are perfect squares. We'll also look at sum and difference of cubes. I don't have that on the screen. And then also we're going to look at factoring by grouping. So first let's look at some of the special cases. So difference of squares. We have two perfect squares and a minus in between. So we are going to use the difference of squares formula. We'll set up two parentheses. And I didn't preface this, but you should always look to see if there's a GCF you can factor out first. There was none here. You would take the first term, which is 4x squared, take the square root of that, which is 2x, put it in both parentheses. Then look at the second term, which is 9, take the square root of that, put that in both parentheses, and one of the parentheses gets a plus and the other gets a minus. And we're factored. So 2x plus 3 times 2x minus 3. Okay, the second example we have, example B, is a trinomial where the first term and last term are perfect squares. So we want to see, because it's a trinomial, if this is a perfect square trinomial. So this one does have a plus as the first sign, and all of them, for them to be a perfect square trinomial, must have that second operation being an addition sign as well. So we will use this for first formula. I'm going to set up one set of parentheses that will be squared. We need to look at the first term, which is 9x squared, and take the square root of that. That is 3x. Let's look at the last term, which is 16. Take the square root of that. And it is 4. And then we are using that first formula, so we have a plus. And that's because we have a plus between the first two terms. So this potentially factors to 3x plus 4 quantity squared. To test that this works without completely expanding out what we factored, we do need to check whether this middle term is equal to 2 times the first term times the last term. So 2 times 3x times 4, does that equal 24x? Well, if I multiply out 2 times 3x times 4, I do get 24x. They equal, so this indeed was the proper factoring, and this was a perfect square trinomial. Let's look at example C. Now, is there a GCF that we can factor out of 8, 24, and 18? Yes, we'll factor out a 2. 8x squared divided by 2 is 4x squared. Negative 24x divided by 2 is negative 12x. Positive 18 divided by 2 is 9. Now, in the parentheses, we have a perfect square is the first term, a perfect square is the last term. So let's try factoring this as a perfect square trinomial. We'll set up one set of parentheses. We have a minus, so we're going to put a minus in our parentheses. The square root of 4x squared is 2x. The square root of 9 is 3. And of course, we would bring down our GCF. Now, to make sure that we factored the perfect square, and it truly is a perfect square trinomial, we need to check whether 2 times 2x times negative 3 equals our middle term, which was negative 24x. Sorry, wrong. we're looking in the parentheses, the negative 12x. So does 2 times 2x times negative 3 equal negative 12x? Yes, it does. So we correctly factored example C. Of course, if you forget these formulas, you can factor using either the x box or the x method, depending upon which one you're using, like we did our regular trinomials. Okay, let's review the sum and difference of cubes formula. So the sum of two cubes, a cubed plus b cubed, factors to a plus b times a squared minus ab plus b squared. And the difference of cubes, a cubed minus b cubed, factors to a minus b times a squared plus ab plus b squared. So let's look at our first example, x cubed plus 8. So what cubed gives us x cubed? X would be cubed. What cubed gives us 8? That would be 2 cubed. So our a in this case is x, and our b in this case is 2. A is x, b is 2. So now let's figure out which formula we are using. We have a sum, so we are using that first formula. So it factors to a plus b times a squared minus ab plus b squared. And let's substitute in the x and the 2. So we have x plus 2 times x squared minus x times 2, or we'll just write that as 2x, plus b squared, 2 squared, which is 4. And using the the sum and difference of cubes formula, that second factor, the trinomial, is prime. So here we have our factoring. Let's look at a second example. 8x cubed minus 27. Is there a greatest common factor we can factor out? No, but 8x cubed is a perfect cube. We can take 2x and cube it. 27 is a perfect cube. I can take 3 and cube it. Now I'm not looking at the minus as being part of the 27 here. So I don't need to have negative 3 quantity cubed. We're just going to look at the number part. So here our a is 2x, our b is 3. We are using the second formula this time, a minus b times a squared plus ab plus b squared. Substituting in 2x and 3, we get 2x minus 3 times 2x quantity squared plus 2x times 3 plus 3 squared. Simplifying that, we get 2x minus 3 times 4x squared plus 6x plus 9. And that is our factored expression. Let's look at factoring by grouping. So you can use this when we have a 4-term polynomial. So for example, x to the 4th minus 2x cubed plus 8x minus 16. And what we're first going to do is group the first two and the last two terms. And I sometimes do this by putting parentheses. Sometimes I'll do it by putting a dotted line that splits the polynomial in half. But you want two groupings. So then we will factor our greatest common factor out of each of the groupings. So in my first grouping, what can I factor out of both x to the 4th and 2x cubed? They both have an x, and the lowest exponent is 3, so I can factor out an x cubed. And that means I will have still in parentheses, x to the 4th divided by x cubed gives me x, minus 2x cubed divided by x cubed gave me the minus 2. So I broke it down to x cubed times x minus 2. And now we'll look at the second grouping, 8x minus 16. What's the greatest common factor there? Should be positive 8. And if I divide 8 out of 8x minus 16, we get x minus 2. So I have this starred because this is important. The parentheses needs to be the same in order for us to continue. Otherwise, you can't factor it using this method, or you might have made a mistake somewhere. So this common parentheses is what we're now going to factor out as our common factor. and we are going to put it out in front. So I have the x minus 2 that was in both the expressions out in front. And then in my second set of parentheses, I'm going to take those GCFs that we factored out, the x cubed and the positive 8. So this factored to x minus 2 times x cubed plus 8. But since we do have a factor that has an exponent, we should check if we can factor x cubed plus 8. Well, this is a sum of 2 cubes. So I have x cubed, which is the same as x to the power of 3. I have 8, which is the same as 2 cubed. So I can factor using a is my x, b is my 2. I'm using the sum of cubes formula. So I have x plus 2 times x squared minus 2x plus 4. And I also had a factor out in front, and that needs to go out front here. So my final factoring for example 3 is x minus 2 times x plus 2 times x squared minus 2x plus 4. Let's look at one more example. Example 4. Here we have a trinomial, 2x squared plus 9x minus 5. So last time we looked at how to factor this using the Xbox method. The Xbox method is really factoring by grouping, just organized in a box. But here we're going to look at how to factor this using just factoring by grouping. So just like with the Xbox, we're going to multiply a times c. So my a term is 2, my c term is negative 5, and a times c equals 2 times negative 5, or negative 10. Then, just like with the Xbox method, find two numbers that multiply to the product a times c, but add to the b term, which is 9. So we need two numbers that multiply to negative 10, but add to 9. So let's look at our factors of negative 10. We could have positive 1 times negative 10, and negative 1 times positive 10. We could have positive 2 times negative 5. We could have negative 2 times positive 5. Those should be the only ones I can think of that multiply to be negative 10, where we have integers. And we need to see if any of these will add up to positive 9. Okay, well, the second pair, negative 1 and positive 10, do. If we couldn't find a set here, then that would mean that our polynomial or trinomial would not factor. So now we will rewrite the polynomial, our original one, the 2x squared plus 9x minus 5, keeping the first and last term the same and expanding out the middle term using the result that we found from the last step. So I'm still going to write 2x squared. I'm going to end with minus 5, but instead of writing plus 9x, we're going to write, using our negative 1 and our positive 10, negative 1x plus 10x. And we're not really changing the value of the polynomial, because if we combine those, we would come back to our original polynomial. We're just expanding it out. Now we're going to use factoring by grouping. So I'm going to separate my first two terms and my last two terms. If I look at my first two terms, what's my GCF? I can factor an x out of both. If I divide everything in the first grouping by x, I get 2x minus 1. In my second grouping, 10x minus 5, what's my GCF? I can factor out a positive 5. When I divide 10x minus 5 divided by 5, I get 2x minus 1. Good, we're doing this right because our parentheses are the same. I'll now factor that common factor out, so I have 2x minus 1. And in my second parentheses, we will put the x plus 5. And that is our trinomial factored. So 2x squared plus 9x minus 5 factors to 2x minus 1 times x plus 5.